So to start our review, the exam will be 5 questions, 75 minutes, 1 hour and 15 minutes, and you will have extra 15 minutes to submit the solution via D2L. First problem, we have a truss. We need to calculate reactions. This is the first part in this problem, reactions. Second part, please identify all zero force members. So let's focus on the first request, reactions. We have A, it's a hinge. So we have two reactions, XA, YA. E is a roller, so we have only one reaction, YE. To figure out these reactions, we have 3 equilibrium equations. Summation f of x equals 0. Guys, make sure you can calculate reactions before Friday. Make sure you can calculate reactions before Friday. We have only XA in the X direction, nothing else. So XA will be 0. Second equilibrium equation, summation f of y equals 0. We have positive YA, we have positive YE, we have negative 15, we have negative 10 equals 0. I can simplify this equation, YA plus YE equal 25. Third equilibrium equation, summation moment at any point equals 0. I highly recommend to take moment at A, and I'm gonna assume this direction is positive. If you take moment at A, I am here at A, so XA times 0, we don't have distance. YA times 0, we don't have distance, plus 15 times 40, plus 10 times 80, minus YE times 160 equals 0. This term will be cancelled. This one will be cancelled. The only unknown in this equilibrium equation is YE. So 15 times 40 plus 800 divide 160. This number will be 8.75 kib. I can go back to this equilibrium equation and put YE equal 8.75. So the only unknown here will be YA. It will be 16.25. So the final conclusion, XA is 0, YA 16.25, YE 8.75. I am done with the first part of this question. Second part, identify all the zero force members. Do you remember we have 2 cases? Do you remember them? Do you remember the cases of zero force member? Case 1, we have a joint with 3 members only. Two of them are collinear. If you watch, this member and this member are on the same line, collinear. The third condition, no external force at this joint. We don't have any external forces attached to this joint. That means the third member will be 0. Case number 2, we have a joint with 2 members only. We have one member like this and one member like this, only 2 members, and no external force attached to this joint. That means the 2 members are 0. Let's try to search for these cases. Do you think I recommend to start with this one first. Do you think we have a joint with 2 members only? Yes, I think. This joint has 2 members. This joint has 2 members. Second condition, do you have any external forces at joint A? Yes, we have reactions. We have YA 16.25. So this joint will not work, and also this joint will not work because we have external force. Reactions are considered external forces. Do you have any joint with 2 members only? This joint, no. This joint, no. This joint, this joint, this joint, this joint, no. All of these joints have more than 2 members. So I am done with case number 2. Let's try for case number 3. I'm looking for a joint with 3 members. 2 of them are collinear, no external forces. No external forces, yes. So this joint will not work. This joint will not work. This joint will not work because we have 4 members. This joint will not, probably. This joint can be work. I'm not sure. This one will not work. What do you think about this joint? We have 3 members? Yes. 2 of them are collinear? Yes. The third member will be 0. Guys, if this member DF is deleted, so this member is not considered. Do you think joint F has 3 members right now? Yes. Do you think 2 of them are collinear? This member and this member are collinear on the same line? No. So forget it. At this joint, how many members do you have? We have 3. 1, 2, 3. 2 of them are collinear? No. Collinear mean the same line, like this or like this. The same line, the same line. So I believe if you search for this truss, the only member which is 0 force member is member DF. Nothing else. So the first problem, I'm talking about the last year. The first problem, I'm asking for reactions and identify all 0 force members. You are lucky, the only member which is 0 force member is only one member, DF. Guys, do you have any questions so far? Do you have any questions so far? So the second question, what do you think about this problem? Is it easy? Is it difficult? Is it impossible? What do you think? It's 20 points. So what do you think? Good? Bad? Okay, looks good. Looks good. This is the first problem in the exam for last year. Second problem. We have a truss and reactions are given. You don't need to search or to calculate reactions. Reactions are given, and you have to trust me. These reactions are correct. Don't worry. So I will not paying any attention to the reactions. At A, it's a hinge. We have two reactions, horizontal and vertical. E, it's a roller, so we have only one reaction, 3 kip. The first part in this problem, I'm looking for internal forces in members AH, this little member, and AB, this little member. So I think we are looking for 2 members. Yeah. And these 2 members connected at joint A. Yeah. So I believe I will do joint equilibrium at A. What do you have at A? Here is joint A. Please include everything intersect at joint A. We have horizontal reaction 0 given. We have vertical reaction 3 kip given. We have inclined force FAB. We have horizontal member, that means horizontal force FAH. Do you think we have anything else at joint A? I believe no. I'm gonna assume this force like this, tension, and this force like this, tension. This angle theta will be included inside this right angle triangle. So the horizontal distance is 5, the vertical distance is 5, this angle will be 45 degrees. We have two equilibrium equations. Summation f of x equals 0. We have 0. We have positive FAH. We have positive FAB cosine 45 degree equals 0. Guys, this inclined force will have two components, one vertical and one horizontal. The horizontal one will be cosine. We have another equilibrium equation, summation f of y equals 0. What do you have in y direction? We have positive 3. We have negative, this vertical component, FAB sine 45 degree equals 0. I think from the second equation, I can figure out the value of FAB will be positive. How much? 3 divide sine 45 degree, it will be 4.24 kip. I can go back to this equation and put FAB equal positive 4.24. So I can figure out the value of FAH. It will be negative 3 kip. I have a question. What is the meaning of positive value? What is the meaning of negative value? Do you remember this concept? Positive value means assumption is correct. I assume the FAB like tension. It's correct. It's a tension. I assume the negative value means assumption is wrong. I assume the FAH like tension. No, it's wrong. It should be compression. So when you are solving the exam, I need to see what is the value, and what is your conclusion. Is it tension or compression? You have to say that. You have to give me a value, right value, correct value, and tension or compression. You have to say it's a tension or compression based on your assumption and the final value, the sign of the final value. I can conclude this member is tension or compression. So I am done with the first part in this problem. Reactions are given. Very simple. I will start with joint equilibrium. Guys, if you are trying to do joint equilibrium, you have to draw this free body diagram. Because some students did not draw this shape, just put equations. It's not good, because if I watch a student like this, I will think he is cheating a little bit. So please don't put yourself in this spot. Second part in this problem. We are looking for internal forces in member GF, GD, CD. Wow, we are looking for 3 members. These 3 members inside the truss. So I believe we have another method. Do you remember? We have another method in truss. Do you remember it? Section. I will do section. And this section will cut 3 members only. That makes sense. We are looking for 3 members, and I can do 1 section to cut these 3 members. I am good. I am good. Keep walking. Keep going. We have 2 options. I can cut and work with this part of the structure, or I can cut and use this part of the structure. Actually, I'm gonna use the smallest part. Both of them works, but I'm gonna use the smallest part. Guys, when I did this cut, I didn't cut in this member, I didn't cut here, I didn't cut here, so this triangle will be the same. So right now, I'm talking about section. I have this triangle. I have vertical reaction 3 kb here. I have vertical force here. How much? 2 kb. You have anything here for this triangle? No. So I did cut in this member, I did cut in this member, I did cut in this member. So I have force here, I have force here, I have force here. I can call these forces FG, FDG, FCD. And the angle is 45 degrees. Guys, 45 degrees because the horizontal distance is 5, the vertical distance is 5, so any inclined angle or any angle for any inclined member will be 45 degrees. Anyway, but please make sure you didn't forget anything. I included this reaction, included this force. I cut here, I cut here, I cut here. You are good. We have 3 equilibrium equation more, but only for this part only. Summation f of x equals 0. We have negative FG, we have negative FCD, we have negative FDG cosine 45 degree equals 0. Summation f of y equals 0. So we have positive 3, negative 2, positive FDG sine 45 degree equals 0. I think from this equation, I can figure out the value of FDG. This value will be negative 1.4. Do you know what is the meaning of negative value? You assumed the wrong direction. So I assumed a tension. I'm sorry, it should be compression. Please don't change anything. I need the value and the conclusion. That's it. Guys, I did only two equations. Summation f of x, summation f of y. So we still have one more equation. Summation moment at any point equals 0. I recommend to take moment at this joint, which called D. Why D? Why D? Because if you take moment at D, f dg will be multiplied by 0. We don't have distance. F cd multiplied by 0. We don't have distance. So I can cancel this one and this one. We have fg times 5 vertical distance. This one 2 times 0. We don't have distance. And 3 times 5. This 3 times the horizontal distance 5 equals 0. The only unknown in this equation is fg. It will be negative also. Negative means you assume the wrong direction. It should be compression, not tension. Once you figured out the value of fdg, the value of fg, I can go back to the first equation to figure out the value of FCD. I am done. So the second problem in this exam, I'm looking for the internal forces in truss member. The first part in this problem, I'm looking for only 2 members, like your exam on Friday, believe me. So I'm gonna do joint equilibrium, only one joint for these 2 members. The second part, I'm looking for internal forces for 3 members at the same location, so I can do one cut. This cut will help me to figure out these 3 members by applying one more time 3 equilibrium equation. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. So guys, do you have any question? Yes. Remember, section method only if you are looking for 3 members at the same location. So I can do one cut for the 3 members. But if I'm asking for 2 members only, believe me, joint method will be the best solution. Okay? Probably in the exam, I will guide you more and more, and I will say by joint method. And the second one, I will say by section method. Just for more guide. Any questions so far? I think the second problem looks good also. Third one. We have a beam and we need to calculate Guys, please make sure and be careful. Make sure and be careful. I'm recording our live meeting and posted them on YouTube. So I'm not sure students don't have enough time to watch these videos. I believe they are watching soccer, football, movies every day. I believe this. But for engineering mechanics, no, they don't have time. They don't have enough time. I'm not sure why. Guys, there is a big difference between calculate and draw. Calculate axial force, shear force, bending moment. Also, draw axial force, shear force, bending moment diagrams. There is a big difference between this problem and this problem. Both of them are talking about beams. But for the first one, we need to calculate internal forces, axial, shear, and the moment at only 1 point. Only 1 point. So 1 point must be given. But the second type of problem, draw. So you need to draw for the whole structure. Make sure you are reading the problem carefully. For this beam, we are looking to calculate reactions. That means we should have a point, specific point. That makes sense. Calculate reactions first. Calculate the internal forces at point D. Point D is at distance 3 meters from A. So this distance is 3 meters. Okay, first part, as requested by the problem, we are looking for reactions. A is a hinge, so we have YA, we have XA. B is a roller, so we have only one reaction, YB. Before applying a equilibrium equation, we have distributed load. Until this moment, some students, I will say few students, still cannot work with the distributed load. Guys, if you have uniform distributed load, you have to make equivalent. This equivalent force at mid distance. So this distance and this distance are equal. How much? 4 meters from this side and 4 meters from the other side. Half distance of 8. What is the value of this equivalent load? Equal the value of distributed load 4 kilonewton per meter time the total distance for this distributed load 8. So 4 times 8 is 32 kilonewton. Once you did this, you are good. Summation f of x equals 0. XA is 0. Summation f of y equals 0. We have positive YA, we have positive YB, we have negative 32, and we have negative 30. Equals 0. So YA plus YB equals 62. Third, equilibrium equation summation. Moment. I'm gonna take moment at A. I'm assuming this direction is positive. If you take moment at A, XA times 0, YA times 0, we don't have distance. 32 times 4, 32, the equivalent force for the distributed load, times 4 minus YB times 8 plus 80 without distance plus 30 times 12 equals 0. Guys, please don't forget we have here a moment 80 kilonewton per meter. Kilonewton meter. This moment does not need distance. Remember this. Remember this. This term will be cancelled. This term will be cancelled. The only unknown is YB. So I can figure out the value of this reaction, 32 times 4 plus 80 plus 30 times 12 divide 8. This value is 71. Okay? Be careful. YB is 71. Positive. You are good. If you go back here and put YB equals 71, YA will be negative 9. What is the meaning of negative 9? Do you know what is the meaning of negative value? Negative value means you assumed the wrong direction. This reaction must be going down, not going up, going down. How much? 9. It's negative. Okay, I changed the direction, so put the value as positive because you already changed the direction. So the final conclusion, XA equals 0, YA equals 9 to down, YB equals 71 to up. This is the final conclusion for reactions. Second part, we need to do cut. Where? At point D. And decide which side I'm gonna use. I will use the left part. It's very simple. So here is the part. Here is the cut at point D. Remember, this part has horizontal reaction here 0, vertical reaction here to down 9, a little bit of the distributed load 4 kilonewton per meter, and this little distance is 3 meters. It's given. You remember that? Point D at distance 3 meters. At your cut, we have normal, we have shear, we have moment. This normal will make tension. This shear will make this part of the beam to rotate clockwise. This moment will make this part to smile. So we have MD, we have ND, we have VD. This little part of the distributed load will have equivalent. If you have any distributed load, you have to figure out the equivalent value. The equivalent value will be 4 times 3, 12. And this distance will be 1.5, and this distance will be 1.5. We have 3 Coulomb equations, summation f of x equals 0. I think ND will be 0. Summation f of y equals 0. So we have negative 9. We have negative 12. We have negative VD equals 0. The value of VD will be negative 21. The third Coulomb equation, summation moment at D, and I'm gonna assume this direction is positive. Taking a moment at D will cancel ND and VD, so we still have MD plus 12 times 1.5 plus 9 times 3 equals 0. So I can figure out the value of MD will be negative 45 kilonewton meter. So the internal forces at joint D, normal equal 0, shear equal 21, moment equal 45 kilonewton meter. This is the third problem in the exam. Reactions and calculate the internal forces. So we don't have something called internal reactions. This expression, I didn't mention this expression. We don't have something called internal reactions. We have supports, so we have reactions. We don't have expression called internal reactions. Doesn't make any sense. What you mean by internal reactions? What do you mean? Reactions mean support. You have a support, you have reaction. We have another expression called internal forces. Internal forces. We don't have expression called internal reaction. I'm not sure what you mean. Okay? Fourth problem. For this one, we need to calculate reactions as a first part. Then we need to draw axial force, shear force, bending moment. So this part or this beam or this problem, we need to draw. So let's start to figure out the reaction. This is a fixed, so we have vertical reaction YA. It will be 1,800. And we have horizontal reaction here, XA. It will be 0. And we have a moment here, MA. This moment, I believe you have to figure out the reactions first. But I don't have enough time. So you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. So you can figure out this reaction. But I don't have enough time. So this moment will be 12,000. Once you figured out the reactions, I will draw vertical lines, vertical lines, vertical lines, vertical lines. Guys, I'm asking for axial force. So you have to draw diagram for axial force. One of you will say, hey, the normal force diagram is 0. Okay, I know, but you have to draw something. During the quiz number 8, some of you did not draw this diagram. It's 0, I know, but you have to tell me. So I don't have any force parallel to this beam. The only force is XA equals 0. So the internal forces or the normal force diagram is 0. You have to draw this. If you didn't, I will deduct 5 points. This axial force is 5 points. If you didn't draw 0, I will give you, or I will deduct 5 points. Be careful. The second diagram is shear force diagram. I will go up if the force goes up. I will go down if the force goes down. But I have to start from left. Here is the left. What do you have at this left? We have force 1,800 up. So I went up 1,800. Walk horizontally. I will walk until this point. What do you have? I have a vertical force 600 going down. So I will go down a little bit, 600 to reach 1,200. Keep walk until this point. We have another force going down. So I will go down by 600 until reach 600. Keep walk until this point. What do you have? I have another 600 going down. So I will go down from 600. I will go down by 600 to reach to 0. This diagram is positive diagram. We are looking to draw another diagram which called bending moment diagram. Guys, when you are starting from left, we have 3 situations. The first situation, no moment at this point. For free end, you have hinge support, you have roller support. So we don't have moment at this location, at the left side. So your moment here is 0. But sometimes we have fixed, and this fixed have a moment. In our case, this moment equal 12,000. So when you start to draw bending moment, the value here is not 0. You have a value here equal 12,000. And this moment counterclockwise, it will be negative 12,000. Counterclockwise direction is negative, but clockwise direction is positive. Okay, so make sure we have a moment here 12,000, and this moment counterclockwise, so we have a negative value here 12,000. So we are looking, this is M1, we are looking for M2, we are looking for M3, we are looking for M4. Let's start. M2 equal, previous value for M2 is M1, negative 12,000, plus area of shear between the 2 points. Many students did it wrongly in the quiz. Guys, between 1 and 2, we have this rectangle, positive. What is the area? What is the area? The value here 1,800 time this distance 3 feet. So I can figure out the value. Negative 6,600. M3. So the value here is negative 6,600. M3 equal previous value for M3 will be negative 6,600 plus area of shear between 2 and 3. We have area here between 2 and 3. This rectangle, positive. What is the value? This height is 1,200 and the distance is 3. This distance is 3. So your value will be negative 3,000. So we have here negative 3,000. M4 equal previous value for M4 will be M3, negative 3,000 plus area of shear between the 2 points. We have between this point and this point, this little rectangle. Positive 600 times 3. Your value will be negative, I think, 1,200. Yes. So the value here is negative 1,200. I am done. Go ahead and connect between this point, this value and this value, this value and this value, this value and this value, and this diagram is negative. Here is the bending moment diagram. Any question? Mitchell, this moment should go to 0, but in our case, we have here a moment given 1200. So your final value must be the same. Just to check. Your final value here must be the moment here. If you don't have moment, this value must be 0. If you have a value, this value on the diagram must be the same value given. Just to check your calculations. So guys, do you have any question? What is the dollar sign here? Michelle, can bending moment diagram be along positive and negative? Yeah, sometimes we have a value here. Sometimes we have another value here, so we have to connect between them. That makes sense. That's fine, based on your numbers. Okay, so no, it's not all the time all values are negative or all values are positive. Sometimes we have positive and sometimes we have negative. If you go back to my meeting on Monday, we have something like this: value positive and another value negative. The last problem in this exam, we didn't cover it yet. It will be included in exam number 3. It is talking about friction.